Good afternoon, everybody. This is our first faculty colloquium in the new academic term, so you are welcomed double wholeheartedly. Especially that we have really a fantastic lecture today by Professor Andrzej Kajetan Wróblewski from this faculty. And really, it's extremely difficult to say things about Andrzej because there is so much to say. With all respect, our professor, the author of textbooks with the late Janusz Zakrzewski, one of the main introductory physics textbook for our students. Then the author of several history books, history of physics, history of Polish physics, any moment to be seen on bookshelves now. Articles virtually everywhere, Wiedza i życie, but not only that. So probably you came across the name, even those who do not study at our faculty, and I think we have some external guests here. But above all, Andrzej is a physicist, and one of the inventors of a formula, of equation, which is Wróblewski formula. Particle physicist, so our colleague in the particle division, and just the professor. So we are happy to have you today and hope to learn about Marian Danish, a legend of this faculty and co-inventor of hypernuclei. So floor is yours.
Ladies and gentlemen, dear colleagues, this lecture was essentially planned for the last year, for the past year, as you can easily judge from the dates here of the life of Marian Danish, because last year there was a 110th anniversary of his birth. For some technical reasons, it was postponed to this year, so we have now at 111th year of the birth of this great physicist. Great, I will try to convince you that he was one of the greatest physicists that Poland produced. I also will show you that his life was quite colorful, and I know it quite well because I was his assistant. He was the PhD advisor of my thesis, and so I hope you will have a good time. First, about the origins. He came from well-known family of scientists, dynasty one could say. His grandfather, Jan Danish, was born in the Prussian partition in the middle of the 19th century, and he escaped the oppression by the Prussian authorities. He escaped to France, studied at the Sorbonne, studied biology, and became quite famous microbiologist at the Pasteur Institute. In fact, he was director of one of the sections of the Pasteur Institute in Paris since 1893. And he became French citizen. He married a Polish woman who also emigrated to Paris. And in 1884, they had a son, Jan Kazimierz Danisz, who studied physics. He was first assistant to Pierre Curie, and after his death, he was assistant to Maria Curie. And he is famous because he has constructed the first ever spectrometer to measure electrons' energy of the electrons. So he was the initiator of beta spectroscopy, one could say. So Jan Kazimierz Danisz also became a French citizen, of course. There was no other way to do it. At that time, he married another Polish woman who emigrated from the Russian partition, from Warsaw to be exact, and they very soon had a son. And the son was registered as Jean-Marie. And this is the first photograph of Jean-Casimir Danish with his son Jean-Marie soon after his birth in 1909. So this is the earliest photograph of our great physicist. Yes? Something is wrong, but it will be corrected soon, don't worry. So we now have the third generation of this dynasty. Jean-Marie came with his father, Jean-Casimir, to Warsaw in 1913 for the following reason, that in 1913 there was a radiological laboratory of the Warsaw Learned Society organized, and the organizers first asked Maria Curie to come to Warsaw from Paris and become the director of this institute, of this laboratory. But Maria Curie was so much involved already in the French affairs that she couldn't do it, of course, but she proposed that her two best assistants, Jan Kazimierz Danisz, or Jean-Casimir Danisz, if you like, and Ludwig Wertenstein will come to Warsaw instead of her, and she would be just a nominal head, and she would act through her assistants. And so it happened. So the Warsaw Learned Society was in this building here. This is the pre-war photograph of the building at 8 Śniadeckich Street. And radiological laboratory was also situated in the same building at the last floor, the topmost floor. It was organized, as I said already, in 1913, and during the first year, it was well organized, equipped, and even the first scientific measurements were done of radioactivity, of course, of various radioactive questions. They had radium sources of alpha particles. And everything went quite well, except that the First World War, broke out. And Jean-Casimir, who was a French citizen, went to France, entered the army. And unfortunately, he was killed just in the very first weeks of the war. This is his monument in Cormicy, where also there is a street of his name, Jean Danish, Rue Jean Danish. And of course, this was a great loss for not only France, but for Poland and for his family. The news about this very sad event reached Warsaw, and it was even noticed in everyday press. This is just an example from Tygodnik Ilustrowany, which was the popular weekly published in Warsaw. And again, it is a small note about the death of this physicist. Now, what happened to his family, of course? Jean-Marie, dit Marianne Danisz, as he is presented in the French sources, remained in Warsaw with his mother, Małgorzata, or Margaret. He went to school in Warsaw. In 1928, he graduated from the Batory Secondary School, regarded to be one of the best in Warsaw at that time, and entered Warsaw Polytechnic to study electrical engineering. But he knew Wertenstein, because Wertenstein was the friend of his father, late father, whom Jean-Marie Danisz vaguely remembered only, because he was only 4 years old when the war broke out, or 5 years old. But he remembered the radiological laboratory, because in his memoirs, he wrote that when he was 4 years old, he for the first time entered the radiological laboratory, and he remembered there was a big table, almost as big as he was at the age of 4, and at this big table there were balls of mercury, which the little boy was chasing. So this was the memory that he had from the pre-war times. Anyway, so he remembered Wertenstein. He visited Wertenstein then later as a student. And in 1930, he became a frequent visitor in that laboratory. He spent first the afternoons and evenings, first learning about physics, because at the electrical engineering department of Warsaw Polytechnic, he didn't have much physics. He was listening to the course given by Wolfke, but it was a very limited course because physics was not regarded to be of any essential value for the future electrical engineers. So he had to learn a lot from Wertenstein concerning radioactivity, the new physics, etc., of which he could learn nothing during his studies. And then there was a first happy event. Let me show you first the portrait of Ludwig Wertenstein, who was an eminent physicist at the time, and some photographs from the interior of this laboratory. It's a well-equipped laboratory. And in 1934, there was a Danish, later explained, a scientific adventure. Namely, Joliot-Curie and Frederick Joliot-Curie and his wife, Irene, announced the discovery of so-called artificial radioactivity. And of course, everyone rushed. Every physicist who had equipment rushed to do something in this new field. And so did Wertenstein, and he was in fact the first. He won this race, on equal footing with Lise Meitner, but he was the first to publish the first paper on this induced radioactivity in Nature. In 1934, Lise Meitner published also simultaneously, approximately at the same time, but in a German journal, Zeitschrift für Physik. And since Danish was a student, he was completely unknown. He was working together with another student, Michał Żyw, who was a student of physics at Warsaw University. Then they found that these alpha particles from a radioactive source could initiate nuclear reaction, which in fact can produce new radioactive nucleus, and you have this reaction written here. Alpha particles colliding with nitrogen 14 gives fluorine 17 plus a neutron. Since Danish and Żyw were completely unknown, of course, Wertenstein wrote a short letter to Nature explaining, as it is shown in the first center, Messieurs Danish and Żyw, working in this laboratory, have bombarded diverse, etc., etc., etc. He wanted to make sure that this paper will not go to the trash bag by the editors, because they didn't know, of course, Danish and Żyw, whereas they knew Wertenstein very well. And then, of course, this paper, as I said, this was the first after the discovery of Joliot-Curie. So this was cited everywhere, etc. And as Danish later recollected, this was a scientific adventure for him, because they spent nights by trying to measure with Geiger counters to measure the radiation, the secondary radiation, by changing targets. That means the gas in the tube, which was irradiated by alpha particles, etc., etc. So this was the first entering of Danish to the scientific stage. And Danish and Żyw were allowed, of course, to publish their own paper in Acta Physica Polonica. This paper was published in French. Acta Physica Polonica at that time was publishing papers in German, French, English, and then it carried a Polish abstract, because the article itself was in French. So this is a Polish abstract of this paper. And then, a few months later, the same group, together with Rotblat, who joined the group, made experiments on the Fermi effect, because Fermi discovered, as you probably remember from your history lessons, Fermi discovered that slow neutrons can collide, when colliding and interacting with nuclei, can produce various nuclear reactions. And so Wertenstein again asked his younger collaborators to study this effect, and this was one of the first papers published in Nature, well-known periodical, explaining this effect. Again, since this was one of the first, it was frequently published before the war. Okay, but then of course, this was a nice adventure. Danish was still a student. At that time, the rules said that Warsaw Polytechnic was not as strict as they are now, of course, and students could stay and study for 8, 10 years, etc., provided they had some means to support themselves. But Danish was in a different situation because he married, and then he needed to stabilize his position, to have means to support his family. So he had to finish his diploma and have money. So he had to unfortunately stop his encounter with Wertenstein's laboratory, and he wrote a thesis. This is the first page of the thesis, and you can see this is in Polish, of course. The title is Shortwave Directional Antennas. Remember, at that time, radio was still quite a new thing, so they were studying antennas. What is amazing for us today is that at that time, diploma works were done in pairs. 2 physicists were the authors, Marian Danisz and Sobiesław Michalski. I couldn't trace Sobiesław Michalski later, what had happened to him. He didn't stay at the Polytechnic, Warsaw Polytechnic. Something happened to him, but I don't know. Anyway, so this was a thesis written together in Polish, and under Professor Groszkowski, who was the chief of Division of Radio Engineering of Warsaw Polytechnic. And let me explain that he was the pioneer of electronics in Poland. He was founder and director of the State Institute of Radio Communication in Warsaw. So this thesis that Danisz and Michalski together wrote was quite complicated, quite involved. It was about 100 pages long, included by bibliography in 4 languages, German, French, Russian, and Polish. And as you see here from these pages, just examples of the pages you was involved. Mathematics was quite involved, etc., etc. They were proposing studying various attachment to this antenna. But Danisz, who was one of the authors of this work, thesis, still remembered his exciting time at the radiological laboratory. So he was a little bit bored with this work that he had to do, of course, to get the diploma. And this is his picture from the time. And if you look at his face, you see he has certain dissatisfaction, disinterest smile of what he was doing. He had to do it, of course, but he didn't like it too much. And this could be well read from his face. Anyway, so he got his diploma, and then he had to do something. So he joined the State Institute of Radio Communication. He joined it in 1938. There was a short break period in between. He worked in the Radium Institute in Warsaw, but he preferred to work at this Institute of Radio Communication. And this is the picture of all people involved, and you see Danisz here. This is Danisz sitting in the first row. This is Groszkowski, the director. This is Danisz. And he was made, Groszkowski thought that he was an able physicist, gifted physicist, so he made him head of the Division of Electronic Tubes at this institute. And indeed, Danisz did good work. He constructed a prototype of a night vision device for which he got a special prize of the Minister of Post and Telegraphs in 1939. But then the war broke, out, and of course everything was finished. Danish survived the Nazi occupation of Poland, and he was employed as a messenger in the municipal tax office in Warsaw. And when the war was finished, he went to the higher technical school of Wawelberg and Rotfand and gave courses on electrical engineering. But again, he was not too much satisfied, so in 1938 he joined Warsaw University Physics faculty at Chorza 69. And remember, physics department did not yet exist as a separate unit. So this was a faculty, was a part of a larger structure. And then, of course, Pieńkowski, Stefan Pieńkowski, who was the boss of this physics faculty group at Chorza 69, had a very broad vision of what Chorza could be in the future. So he was eager to enlarge the field of research from optics, which was the field of research before the war, to nuclear physics, solid-state physics, particle physics, etc., etc. So he somehow arranged that Danish went to England. First, he spent some time in Liverpool, but then he was not too much satisfied. In Liverpool, he joined his old friend from radiological laboratory, Joseph Rodblat. But he preferred to go to Bristol because in Bristol, Cecil Powell, later Nobel Prize winner, discoverer of the pi meson, had the best laboratory at that time. And this is again a very nice photograph of Danish and his colleagues in Powell's laboratory. And in the front row, you have from the left Cecil Powell, then Gideon Yekutieli from Israel, Marian Danish, and Owen Locke, the four young physicists. The rest are scanning girls, technical personnel, etc., etc. And Danish was very much satisfied by his work. And he learned the technique of nuclear emulsion, of course, and well, there was a spectacular failure. By studying different interactions recorded in this nuclear emulsion, Danish, Locke, and Yekutieli noticed that there are groups of pairs of tracks which are close together, emitted from these interactions. And the percentage of such pairs for them was larger than resulting from the pure random. So they thought that this is probably a new particle, they call it zeta particle of mass of about 500 electron mass, which decays with a very small decay value, and this was published in Nature. And as you see here, they announced that there will be a larger publication, more detailed publication in the Philosophical Magazine, which never occurred because very soon when they had more interactions, it appeared that it was just a fluctuation, Then there is a story later on when Danish was in Dubna, and this was a well-known story, of course, of this failure. Then there was a jocular verse coined in Dubna, which makes sense in Russian, of course, but some of you may know Russian or understand Russian. So the verse went as follows: Danish lokent Yekutieli, romizon naitihatieli. Which in English, of course, doesn't make any sense. It does no longer a verse. Anyway, so this was a failure, but it was not all, because at that time, we are now in the year 1952, and there was a chaos, complete chaos in this particle physics field. This is the table of these new particles, so-called V particles and heavy mesons, as presented in December 1952 at the Rochester Conference. And as you see here, there are many particles, and most of the symbols are question marks, because almost everything was uncertain. Only in two cases, the so-called V01 particle and V02, there was something that was presented here without question marks. All the rest were question marks. The zeta particle of Danish and Locke and Yekutieli was still presented here with question marks, of course, with question marks. So remember, this is December 1952. It's very essential because this is the year in which everything crucial happened later. Anyway, I mentioned that in December 1952 there was a Rochester conference, third annual Rochester conference. Robert Oppenheimer was one of the participants, and he then summarized it, made a conclusion. He was so much dissatisfied with the state of the field that in his conclusion he wrote the following: I hope our grandchildren will, when they attend the 2038 conference in Rochester, will take it for granted that they know these things. It is unknown, of course, why he took so long, more than 80 years. In fact, after about 10 years, everything was more or less clear. Anyway, but this shows you how chaotic the knowledge of these new particles was at that time. And then Danish returned to Warsaw in May 1952, and he began to set up nuclear emulsion studies at Chorza 69. The equipment was quite simple. First, just ordinary microscopes. Later on, more specialized microscopes had to be used, which allowed precision of about a fraction of a micrometer. But at the beginning, this was very simple microscopes. And in fact, very soon, after a few weeks since the beginning of his arrival, there was a discovery of hypernuclei. And I will show you here the description of it as recollected by Jerzy Pniewski, but since I see some young people at the audience who may not know what hypernuclei are, so let me explain very briefly that these are nuclei in which one of the neutrons, like in this example of helium-4 nucleus, is replaced by a lambda 0, which was at that time called V0 particle. And the presence of lambda particle in a nucleus allows to have some very exotic hypernuclei, which could not be achieved without lambda particles. For example, hydrogen-4, including a lambda particle. Oh, this is because of Pauli principle, which doesn't work for lambdas, etc., etc. So, okay, let's go back to Jerzy Pniewski. This is my English translation of his autobiographical remarks. Late in the evening of September 19, we began to analyze the recorded events. Suddenly, Marian exclaimed, "Look, what a strange animal," and showed me two stars connected by a prominent and quite thick track. It was obvious that one of the stars was due to a disintegration of a heavy emulsion nucleus, silver or bromine, by high-energy cosmic radiation proton. The nucleus was split into small fragments, and only one of them, distinct by its quite long track, seemed to have mass considerably larger than the others. Its track ended with a four-pronged stars, which indicated its spontaneous decay. This is the picture of this event. And then Pniewski continued. The energy released in this decay was clearly very high, which was confirmed by subsequent measurements. But then the lifetime of the fragment, estimated from the length of its track, was unbelievably large for such an excitation. We spent nearly 3 weeks on endless and heated discussions, during which we eliminated various explanations of the observed inconsistencies. We concluded that given the conditions of exposure of the emulsion stack, an accidental juxtaposition of two unrelated events was completely improbable. Twice a day, we went for coffee to Café Niespodzianka, and it was there that we suddenly began to see daylight. That so large energy released in the secondary star was comparable to the energy of annihilation of the pi meson, the particle discovered 5 years earlier. The first hypothesis was that the fragment carried a bound pi minus meson, similarly to an electron bound in an atom. This very attractive hypothesis had to be rejected because it was improbable that the fragment could capture and carry away one of the mesons produced in a high-energy collision. But we were only one step from the proper interpretation, that the fragment contained a bound V01 particle. This V01 particle was discovered in 1951, or 1 year earlier, by Armenteros, but no one expected that it could be bound in an atomic nucleus with protons and neutrons. We treated it and as an excited nucleon. Our interpretation made it the third component of atomic nuclei besides protons and neutrons. We dispatched a short paper to the Bulletin of the Polish Academy of Sciences, and then we sent letters to several foreign physicists, including W.C. Werner Heisenberg, Cecil Powell, and Dmitry Skobeltsyn. Skobeltsyn was a Russian pioneer in cosmic radiation. Danish didn't know him personally, and perhaps the choice of Skobeltsyn was because of the present situation, political situation. As you may not know, or you may remember, 1952 was not the time of very comfortable political situation in Poland. And it was the top of the Stalinistic era. And Danish and Pniewski wanted, probably by sending a letter to Skobeltsyn, to somehow show to the regime that they are eager to collaborate with both West and East. Anyway, the answer from Skobeltsyn never came, and it is not even clear whether he got the letter. But Heisenberg and Powell got the letters, and there were answers by them. This is Jerzy Pniewski on the left-hand side and Marian Danish on the right-hand side. Now, as you remember, they sent a short paper to the Bulletin of Polish Academy of Sciences, and it carried the date of October 20, 1952. The first, on the 26th of October, they sent a letter to Powell. And this is the original of the letter, which is hard to read, but the most important part are the following, more or less. It is more than, this is the original, so including some mistakes, orthographic, etc., etc. It is more than 4 months as I am back in Warsaw. The summertime, time of holiday, was a dead time for me. Nothing happened. It is already over. From September, the work has begun, and I hope to have some prospects for the future, etc., etc., etc. With this letter, I enclose a short note concerning a star of a rather exceptional character. We have worked on it with my friend J. Pniewski, who will, I hope, continue to work with me on the plate technique. If you find the whole problem not unreasonable, we might send later a fuller account to Philosophical Magazine. We would be very grateful for all suggestions and comments, criticism. As you see, Jerzy Pniewski was a newcomer, complete newcomer. Danish had a training in Bristol, but Pniewski started his career in optics, then he shifted to nuclear physics. He made a thesis on beta spectroscopy, and he was very reluctant to again change his field of research. And that's why Danish says, Jerzy Pniewski, who will, I hope, continue to work with me, etc. It was not yet clear whether they will work together at that time. Anyway, the first answer came from Gottstein, Klaus Gottstein, with whom Danish worked in Bristol, because Danish didn't know Werner Heisenberg personally, so he sent the letter to Gottstein to be shown to Heisenberg. And Gottstein was quite enthusiastic. He said, yes, I think it's very interesting. Professor Heisenberg is also read your letter with great interest, etc., etc., etc. The reaction of Powell was completely different. This is his letter, November 19th. Dear Danish, thank you very much for your letter of the 26th of October. The event is certainly most striking, but I feel that you would be well advised not to publish it at this stage. In spite of the most remarkable precision with which the heavy particle ends its range at the point of origin of the second star, you still have to meet the suggestion that you are dealing with a change juxtaposition of unrelated events. Because of this, I think it would be best either to wait until a second example of the same phenomenon is found, or to publish a photograph of it with a minimum of descriptive material. There seems to be no point, for example, in giving a detailed description of the big star. from which the heavy particle was emitted. So you better wait and do nothing. Fortunately, they didn't listen to his suggestion. And this is the timetable of this very dramatic period at the end of December 1952. So discovery was September 19, paper submitted October 20 to the Bulletin of Polish Academy of Sciences. Danish to Powell wrote on 26th of October. Goldstein to Danish wrote an enthusiastic letter. Wow, yes, it's very interesting. Powell to Danish, you better wait, you better wait. And then the very same day, Danish got a letter from a certain physicist from Imperial College London named George, who said the following. Well, Danish, we have heard a rumor that you have such a peculiar event in Warsaw. I have to inform you that we have similar event in Imperial College. And if you are interested, perhaps we could publish the two events together, because two events are better than one. Danish, in fact, who was still very uncertain because he was a newcomer in this field as well as Pniewski, he was sympathetic to the suggestion. And he wrote a letter, why not? Yes, perhaps two events are better than one, so perhaps we would write a common paper to Philosophical Magazine. But then Powell learned about it and said, no, 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 because he learned that these people from Imperial College London had their event much earlier than Danish and Pniewski. But they didn't understand it, they put it aside as some coincidence, etc., etc. Only when they learned about Danish and Pniewski event and also of their interpretation as a new phenomenon, they said, aha, so we may join. So Powell said, no, no, the priority of Danish and Pniewski must be preserved. So in fact, he saw to it, and he was a Nobel Prize winner, so he had the power to do it. He saw to it that Danish and Pniewski paper was published in the Philosophical Magazine with the date of submission of December the 1st, and then the Imperial College London paper was published with the date of December 15, and it carried already a reference to Danish and Pniewski. So in this way, the priority of Danish and Pniewski was preserved. Otherwise, the priority would be somehow diffused because there were more authors in this Imperial College. There are 4 authors, so discovery made by 6 people was not a good discovery. Anyway, very soon, January 5th, 1953, the second hyperfragment was found by Crussard in Paris. And then July, the same year, 1953, there was a conference in Bagnères de Bigorre in the French Pyrenees. This was the first conference during which the hyperfragments were discussed. And this was, now this is a photograph of this first page of Danish and Pniewski paper in Philosophical Magazine. In Philosophical Magazine with a enlarged photograph of this first hyperfragment. Now, the Bagnères de Bigorre conference was very essential because there was some order, at least, was made in these new particles. The names of hyperons were proposed for these heavy particles, etc., etc. And the proceedings of this conference carry a very jocular motto. The particles described in this conference are not entirely fictitious, and every analogy with the particles really existing in nature is not purely coincidental. Anyway, so this was the first conference during the hyperfragments were discussed. And of course, the research went on, except that Powell remained skeptical. Powell remained skeptical and in the paper that he dispatched to Nature on September 12th, so after the Bagnères de Bigorre conference, he said, yes, first observed by Danish of this process, but alternative explanations cannot at present be excluded. Cannot at present be excluded. So he was skeptical. Well, who knows? And then, after a few more months, he realized that this is extremely important discovery, extremely important discovery. The original discovery suggesting that lambda zero hyperons can exist not only as free particles, but also bound within nuclei, was due to Danish and Pniewski. An excited hydrogen atom, to use the simplest example, consists of a proton and an electron in a state of higher energy than in a normal atom. The analogy might then suggest that the excited nucleon consists of a proton and an associated pi minus, that the lambda 0 is composite particle. Such a view could not have been finally excluded, while our knowledge was confined to the decay of the free lambda particles. These considerations suggest that the lambda particle is an excited nucleon in a different sense from that suggested by familiar analogies. We are entering a new field where basically new concepts remain to be established. So this was the final realization that this is extremely important because it opens a new field. This is a new particle which can be a component of atomic nuclei. Nobody realized that this is so. Well, Danish realized that the knowledge of lambda mass was very poor at that time, so he decided with his younger collaborators, students and collaborators, I was among them, as you see from the list of authors, to perform a very exact measurement of the lambda mass. So we spent about 2 years on measuring it, on correcting all possible angles. And when we published it, this was the most precise determination of lambda mass at that time. And it remained so for several years. It entered the particle data table of that time. And we were very proud to see our result quoted there, because Warsaw suddenly became a laboratory with quantitative, very precise quantitative results. Danish and Pniewski worked on hypernuclei for quite some time, and this is another discovery that he made, a suggestion that there are isomeric states of hypernuclei. They noticed some anomalies with the observed value of decay of hypernuclei of helium-7 and lithium-7, the isobars. They must have been the same if everything went according to textbook, so to say. So they suggested that there are excited states, isomeric states of hypernuclei, and this was the beginning of hypernuclei spectroscopy, which was going on later on. And then the big triumph. A big collaboration was organized with 8 participating laboratories of Europe to study hypernuclei, to collect as large statistics as possible. And it happened so, stroke of luck, that in Warsaw, the first and only double hypernucleus was discovered. And so in the publication, here you see the first page. The first time, it started with Danish, Garbowska, J. Pniewski, Jerzy Pniewski, Tadeusz Pniewski, and Janusz Zakrzewski, and then some participants from other laboratories. And this was another breakthrough, because for the first time, it appeared that there could be hypernuclei more complex, that 2 nucleons would be replaced by 2 lambda particles, another direction in this study. The event itself was extremely complicated. This is the microphotograph. All this, just you have to notice this, all this was confined in a volume of about 3 cubic micrometers. 3 cubic micrometers. And then, of course, after weeks and weeks of trying to understand what's going on, finally the solution came, the following, that this was a K minus colliding with the nucleus, and the psi particle, doubly strange particle, was emitted. It interacted with carbon-12 nucleus, produced double hypernucleus beryllium-11 containing 2 lambda particles, and this was, of course, not stable. So it first decayed into single hypernuclei, beryllium-9, and then D was another decay of beryllium normal hypernuclei. So this was beginning of a new field in the study of hypernuclei. 10 years after the first discovery, this publication. There was already an international conference on hyperfragments at Saint-Sergue. And as you see, this familiar, by now, photograph was still shown up. In fact, it became sort of an icon because it was reproduced everywhere at the covers of various periodicals, etc., even in post stamps and stamps and etc. So it really was reproduced hundreds of times. It's still a very familiar picture. This field was very quickly growing. As you see, this is the statistics of papers on hypernuclear physics. Experimental papers were more frequent at that time, of course. There were some theoretical papers as well and some reviews. Altogether, during this period, there were about 500 papers published, and each of them cited Danish and Piewski. So you had a lot of citations, etc., etc. Okay. And then, of course, nuclear emulsion had a very limited use for particle studies. So part of Danish laboratory entered a new field, bubble chamber studies. For this, the number of events was collected in bubble chambers. We needed much more computing power. One couldn't buy a computer at that time because of embargo. So even if one had money, one couldn't buy a computer. And there was a crazy idea presented by a gifted electronics engineer, Jacek Karpiński. He approached Danish and Piewski and said, I will build a computer, provided you give me money for components and for people whom I will hire. And he did it, and he did it. Computer was planned to be ready at 1965. It was delayed a few months, a few years, in fact. He was ready only in 1968, but it worked. It worked. This was a very well-working computer on which our work with bubble chambers was based for many, many years until the early 19th. And then there was another chapter opened in Danish life. Namely, he was called to the Joint Institute of Nuclear Research in Dubna. Joint Institute of Nuclear Research was organized in the Soviet Union as a reaction to the organization of CERN. And they wanted to maintain international character of the institute, as CERN was an international institute, or at least they pretended to have this international character. So they decided to have vice directors from the member states of the Soviet area of influence. So Danish was asked to be one of these vice directors, and the second was Václav Votruba from Prague, a theoretical physicist from Prague. And here is a photograph showing Dmitry Blokhintsev, who was the director, and Danish, who was obviously not satisfied with what he was doing. He hated administration, in fact, and Votruba. But of course, he realized that he has opportunities now, meeting other physicists. This is a photograph showing a visit of Paul Dirac in Dubna. So again, we see here Paul Dirac, Blokhintsev, Danish, here Nikolai Bogolyubov. So he had a lot of opportunities to meet other people and to exert his influence. Remember, in 1956, he was a very, very well-known and influential physicist, known all over the world. Russia at that time was nothing, was a closed country. So using his influence, Danish opened Dubna to other countries. He started collaboration with CERN, etc. He also was very active in sort of political events. He was the member of the first Pugwash conference in 1957. which was organized in Canada by Cyrus Eaton, the Canadian millionaire. And this first Pugwash meeting, this was a meeting of scientists who wanted to somehow protest to the politicians that not the arms race, but investment in science, health service, etc., should be done. So you see here Danish, and here with a cigarette in his hand, and there was a number of other famous physicists present from Japan, Tomonaga, for example, Yukawa, Weisskopf, and Powell was also present, and there's this Powell here, Rotblat, etc. So he was influential. He knew a lot of influential people, Danish, and he could do a lot. Here he is shown chatting with Victor Weisskopf, director of CERN. So he was on good terms with very important people. In fact, the people in Dubna remembered very well this, what Danish has done for them. And in the 100th anniversary of his birth, they organized a special seminar. Again, you see the photograph of the first hypernucleus. There was a special seminar organized in which there were 3 speakers from Poland, in fact, Wicech and Richard Sosnowski, who is sitting over there. He had a talk, Nasz professor, our professor, and then the 3rd participant was Jan Danish, a son of Marian Danish, about whom I will see a few words later on. So they really celebrated this person. There were very nice memoirs written about him and praising him for what he did for Dubna. He also took part in some other important events. This is a photograph of the participants on the 100 years anniversary of Maria Curie in Warsaw, 1967. You see Danish here with a cigar. Now, he hated orders, and etc. He wanted to be a humble, modest physicist, and he didn't have any degree, remember. He was only electrical engineer. So we tried to persuade him that he should have some degree. And he said, no, give me in peace, give me alone, give me alone. It went so for several years. And then one day he said, okay, I agree, give me an honorary degree of Warsaw University. And then he turned to me, but you will promote me. Of course, for me, it was a big honor to promote my boss and etc. So these are a series of photographs. It happened in March 30, 1977. Jerzy Pniewski, shown here, was a dean of our department, physics department, and he is Marian Danish and rector of Warsaw University at that time. As you see from other photographs, he was obviously bored, Danish, because he hated such events. And when he was asked to say a few words, he did it, but with distaste, so to say. And of course, this was a big event. This was a big event. And so many people from all over Poland came. And as you see, there are very famous people. Most of them are no longer alive, except for a few. Here you see Professor Iwo Białnicki-Birula, who sits here in the front row. So he is still alive. And there are a few more who are still alive. But all the rest, Professor Piotrowski, Sosnowski, Szymański, Białkowski, Karczewski, Zakrzewski, they are all no longer with us. And there were also quite a number of foreign guests, such as Charles Peyrou from CERN. And Danish felt himself well only in the company of his best friends. Owen Locke, who came also, of course, to celebrate Danish, Cormac O'Kealy from Dublin, Ireland. So this was the situation in which Danish finally could relax and could smile. So he accepted, so he is an honorary doctor of Warsaw University. Now I come to the last part of this talk concerning private life and hobbies. Now, one hobby you may guess, his chief hobby. This was smoking, because previously I showed you several photographs with cigarette, with cigar. He has smoking pipe on this photograph. And he was a chain smoker. He smoked everything: cigars, pipe, cigarettes, whatever he had at hand. And this, in fact, killed him, finally. He didn't live long. So this was his chief hobby, smoking. Now, he was married 3 times. I mentioned already that he was married during his student's time. His first wife was Hanna Ślewińska, and they had a son, Jan Arthur Danish. Of course, Jan was a sort of perpetual name in this dynasty, who was born in 1937. And during this period, in fact, the French Republic called Danish, Jean-Marie Danish, who was still a French citizen, for a military service. So Danish had a military service at Strasbourg in France, and his wife, Hanna Ślewińska, commuted between Warsaw and France to visit Danish. And on the way, so to say, to Strasbourg or from Strasbourg, the son, Jan Arthur Danish, was born in Poznań, just halfway between Warsaw and Strasbourg. Now, something happened just before the war, in 1939. The marriage broke down. As recollected later by Jan Arthur, who knew it from his mother, Marian Danish one day simply left home and disappeared. And simply disappeared. And then, of course, there was a Nazi occupation. So he was working in Warsaw Municipal Tax Office, and probably he was at that time connected with another woman, another wife, who was Wanda Rynke. Nothing is known about her, except that she probably might have been the reason for the breakup of the first marriage. And again, this was soon finished. And the third wife was Eva Garber, an architect, who stayed with Marian till the end, and in fact passed away a few months after he passed away. They are buried together in Powązki Military Cemetery now. Now, another hobby of Danish was driving. He was driving a Russian-made Volga. Now, of course, very few people know what a kind of a car it was. It was a very solid car, very heavy, solid car, resembling a tank rather than a car. And Danish's principle was to drive as fast as possible, no matter what. Of course, the traffic on Polish roads was much less dense than it is now, but there were tractors, horse-driven carriages, etc., etc., and it was still very dangerous to drive fast. Danish didn't pay attention to any of this, and for some unknown reason, he was lucky. He was lucky because he never had a serious accident, but it was very, very exhausting for the passengers that had to be with him in the car. One example of which I was my witness was the following. One year we invited Leon van Hove, the director of CERN, to Poland. We wanted to go to the Mazury Lakes to have a discussion and one of the houses there. And so Danish took van Hove to his car, of course, and they were driving fast. I was following with my car and my colleagues were. And then, of course, I couldn't follow him because of self-preserving instinct. So I was behind him quite a distance. And then at one point, he stopped on the side. And so I stopped also behind him. And there was van Hove who went out of his car, completely exhausted, with white paper, face pale as white paper, and he said to me, "You know, Danish has an interesting way of driving. He always waits until the situation becomes interesting." This was a very fine understatement, because Van Gogh was a Dutchman, but he behaved like an Englishman, so he was always talking in terms of understatements. So this was another hobby of Danish. And then, of course, driving so fast, he, from time to time, he had success in killing some hare or whatever. So this is a photograph taken by Richard Sosnowski, who is sitting over there. Marian Danish roasting his prey at Lake Servy. He came to Lake Servy when we were camping. Richard and I and our families were camping. You see here, some of you may recognize my old car up there. Danish came with a hare, he collected on the way, so to say, so he was roasting him. In fact, one of the hobbies of Danish was also eating. And he liked to eat well and a lot. In fact, it contributed to his deteriorating health, because he was starting to be obese and etc., etc. Just to give you one example of something that I was again a witness, he has heard somewhere that brown bear meat is a delicacy if well prepared, and especially the paw of brown bear. Of course, brown bear in Poland is a protected species, but in Russia it's not. So through his contacts with Russian hunters, he somehow acquired a paw, bear's paw, frozen. He brought it to Warsaw. This was a piece of meat about 20 kilograms, because bears, are, as you know, are very heavy. And he made sure before that there is a cook in Jaburna Palace, a chief cook, who knows how to prepare bear's meat. So bear's paw was transported there, and after a few days he invited us. Richard was there, I was there, and a few more people, and we were all treated with bear's paw. It was very good, I must admit. Anyway, his another hobby was hunting with rifles. He was hunting mostly small birds, quail, partridge, ducks, etc., etc. And this was his hobby, and he went there as often as he could. So his life was quite colorful. I must say, I could tell you more anecdotes from his life and my own experience, but it's time to finish it. Let me only show you here the article which appeared in CERN Courier after Marian Danish died, and in fact all his achievements here in promoting international cooperation was explained here. So he was really a physicist of the first magnitude, so to say. So let me finish with the following remarks. Louis Pasteur once said the following: in the field of observation, chance only favors those minds which have been prepared. But there is another quotation which I like very much, and this is from Cecil Powell, from his after-dinner talk at Saint-Cyr. And Cecil Powell told the following: I am reminded of a famous remark of Napoleon. Whenever he was presented with a young man for military advancement, he invariably asked the question, is he lucky? This was by no means a casual inquiry. The important quality for which he was seeking was, does this man put himself in a situation where he can be lucky? If you fail to put yourself in a situation where it is possible to have good fortune, then you cannot have any success. If you do, you may. And indeed, if you look at the achievements of Marian Danish, he was a lucky man. He was a lucky man. Remember, the first hypernucleus was found few weeks after the beginning of study the machine in Warsaw, just after the beginning. So, and then a double hypernucleus was found in Warsaw, again, one of the 8 collaborating laboratories. Again, stroke of luck. So he was a very lucky physicist. And he was also well prepared, otherwise he couldn't follow this. So my conclusion was that he and Pniewski were two well prepared and lucky physicists. Thank you.
Well, thank you so much for this colorful remindings. Maybe somebody can add something, a comment or a memory. No questions then.
I'm happy that it seems that everyone is satisfied.
Yeah, but I think it's a very interesting.
Yes.
Yeah.
Oh yes, he had a dog, of course, Tavi, from Rikki-Tikki-Tavi, from Kipling's novel. He had a dog, and the dog was almost always residing either in his office or in his car. So the interior of his car looked rather like a dog house than a car. It was never cleaned up. It was a very colorful dog as well. Yes, I agree. And who? Oh, okay. If you ask me, I will tell you. The story went as follows. Danish once came to us, Richard and me and our families were camping at the Lake Servi, and for the first time, he came with his dog. And the dog, of course, was unaccustomed to big, deep forest, and he was afraid. And he was barking and making noise all the time. So we couldn't sleep all night, in fact. And so next day, we started to think what to do to provide us with possibility to sleep. So we decided to give the dog a sleeping pill. And Danish, when we told him, well, you should do something with this dog, and I said, oh, no, just wait. The second night will be better. He will be accustomed to this forest, etc. But we never believed Danish, so we preferred to take the affair in our own hands. So the dog got a sleeping pill in a piece of meat. And in fact, the second night he slept all the time. We also slept, and Danish the next morning was satisfied. I told you that the second night will be better.
Experimental attitude, not checking all circumstances. Okay, more questions or remarks? I cannot say that my generation really remembers him. I remember there was a person like this walking around, indeed, with a dog at his foot, and a huge pipe, and leaving lots of pipe smell behind, which was always a sign that such a person passed by. But I cannot really say that we really sort of appreciated his personality or his achievements. No. I could say it was a pity I guess he was never connected to the university, right? He never gave any courses or...
No, he did.
Did he?
Yes, oh yes, sure. Ah. In fact, he never gave courses, the ordinary, just regular courses of general physics to physics students, but he gave it to students of geology, biology, and I know some people who were his students from geology department, biology department, and they liked his lectures, in fact.
But not diploma
in physics,
students.
He only gave, as we call, monographic lectures on particles, etc.,
okay.
etc.
So that's why we couldn't know him. Mm-hmm. More? No, so I think we shall thank Professor Wróblewski again. Thank you.